Hi everyone, welcome to today's webinar. We are going to be focusing on how you can get started with Path Explorer for Greenfield road projects. If you haven't been to one of our webinars before, my name is Erin. I'm the Business Development Manager at Softree and our resident webinar host. And with me today is our training manager, Matthew Dickey. So today we are going to be going through a whole bunch of content to help you sort of kickstart your understanding of what Path Explorer AI can do, and really kind of understanding what the tool is capable of, how you can control it. So we're going to sort of foundational session focused on core concepts. So to start, we are just going to look at what is the workflow for working with Path Explorer. What are some of those key functionalities that it includes? From there, we're going to take a look at how to define and work with construction zones. So really that's just the ability to add spatial constraints to Path Explorer. So we'll look at that. And then we're going to go into a section where we tackle a couple different topics. First and foremost is we're going to be talking a little bit about accuracy, what accuracy means inside of Path Explorer, how you can control it, how you can improve upon it, and of course, maybe when it's time to make it a little bit less accurate to help your problem size. We'll also be talking about control points and then how both accuracy and control points can apply to concepts like long roads. So of course, the longer the road, the bigger the problem. And we're going to talk about some levers and some tools you have to help you solve those long road or long corridor problems. Finally, we'll take a look at how you can take a Path Explorer path, turn it into a full generated geometric road design with a click of a few more buttons. But first, like I'm going to say it's a little bit of housekeeping, but more of just a bit of context. So Path Explorer itself is actually not a product that we sell. You can't just go and say, I want to have Path Explorer. Path Explorer is actually a feature within our main product, which is wrote into Softree Optimal. And it's not just a regular feature, it's something that we call a support exclusive feature. So if you are a current client of ours and you're on support, this function is possibly enabled in your software depending on your version. If you don't have those things, you're not going to see it. So I know this is a point of confusion, and that's why I wanted to add it to our content today. So we're going to dive right in, a lot of stuff on the agenda. And I guess my final piece of housekeeping before I tackle this slide, really, if you have any questions throughout the presentation, type them in the chat. You as a question asker will remain anonymous. We'll hopefully get to tackling all the questions at the end of the webinar. And with that, let's talk a little bit about what is Path Explorer. So I mentioned it's a function. You can actually see it here in the toolbar inside the presentation screenshot. So yes, it's a feature and function inside of the terrain module, and it utilizes a tin surface for creating, for the accurate terrain modeling, and then it dynamically searches the 3D space to find the lowest cost alignments between 2 points, A and B. So we've got a feature, it's got a start point and an end point, and we're going to look to figure out how to best connect those with a road, considering some very road-specific variables. For example, your road width, your minimum maximum grade, if you've got side slopes, so what can those be? Your max cut, max fill, so your vertical offsets, your minimum horizontal curvature, as well as some other geometric constraints. So Path Explorer is going to do this and then come back with some solutions depending on how many you've asked for. It's really worth noting, and maybe going back actually for a second, it looks like that we're just giving you a line on the map, but behind the scenes, it's not just a line on the map. It's really solving an incredibly complex three-dimensional road-specific problem. And this is a bit of the lens of what Path Explorer looks at it through. So I should note, it is a simplistic cross-section. It's not looking at, including ditches, including retaining walls. It's just a simple trapezoidal cross-section. But this cross-section has a few different elements that you, as a user, can control when we're asking Path Explorer to search for us. So the first thing you can control is your road width. I had mentioned the cut and fill slopes. You can control those. And then it's also going to look at cut cost, fill cost, and surfacing cost. And if you're like me and sometimes not quite sure what your exact costs are, that's okay. Because at the end of the day, we found that, most typically the road that moves the least amount of earthwork is going to be the one that's going to have the lowest cost, generally speaking. Of course, we all know there's exceptions to that, but as we look to minimize cost, that's what Path Explorer is doing. And really, as I mentioned, that foundation is whole sitting on this idea of cost optimization. But this is one of those, I'm going to say, really unique scenarios where minimizing cost is actually really complementary to another goal that most of your projects probably have, which is minimizing their environmental impact. So when we maintain natural drainage, we minimize our disturbance area, our project footprint. We're going to minimize earthworks, which minimizes emissions and construction effort. And Path Explorer allows us to account for, say, environmentally sensitive areas and make sure that our road locations are not going through them. So really a lot of positive things that can come out of leveraging Path Explorer when you do it correctly. Okay, we're almost ready to go for example number 1 to Matt, but let's first just briefly talk about a couple of the inputs that you as a user would need to put in. So to start, you need a tin surface. That's kind of common in pretty much anything you do inside of RoadEng. So we're going to bring in some survey data. We're going to create a tin surface, so a triangular irregular network. Then you're going to select a start and end point. This can be a crazy looping feature, but all we really care about is the start and the end point. So an A to B feature. Then we're going to configure some design parameters. These design parameters can be how many path options you want to see, your minimum horizontal curvature, your road width, remember simple cross-section like I showed you before, so that's going to include the ditches and the width, and then your construction parameters. So we can set these up and then we can run Path Explorer. And for the first example we're going to do here today, we're going to skip this next step, which I've got here on my list here of inputs, which is construction zones or zones of different cost. So we'd love to let you understand a little bit about what the tool's doing. The other input that we have at our disposal, as well as this idea of an approach direction. So on my little screenshot on the left, we certainly don't want to go loop back across the road or double back across it. So we can use approach directions to control Path Explorer a little bit to make sure it's giving us results that start in the directions that we need. And here's an example of what that one could look like. So with that, I would say arguably far too long and not very well practiced introduction, let's get into the first example. We're going to take a look at sort of high-level workflow for Path Explorer and some key functions. And with that, I'm going to share it over to Matt.
Awesome. So I'll take the screen and we're going to start right from square one here, but we're going to start with a simple example. So as introduced, we're doing this in terrain. We're clicking insert file, and I'm going to grab my surface data. So in this case, I'm bringing in a DEM. I'm going to model my tin surface, and here I'll just leave my contours off. So we have a surface. And if I want to use Path Explorer, well, I totally can. And I'm going to go new feature. I'm going to click in a start point. And I'm going to click in an end point. And so as Aaron said, if I want to run Path Explorer on that feature, it's not going to matter if I have a bunch of points in between that start and end point. It really is just going to look at the start, end, and away we go. So I'm going to click the optimization tab. To start here, I'll just run with all my default settings. I'll see what it produces. And depending on the problem size, it might take, well, a few seconds to several minutes. So it says unlikely to improve. I'll hit cancel. And we see that we've got, well, a few different road options heading up in the direction we'd like. Now, if we wanted to iterate this and try different things and see what changes with different design specs, well, we could do that. I could just come in here and I could leave the remove existing features, and let's see what happens if I set my max grade at 12%. So it says unlikely to improve. Let's see what it gives us with that 12% constraint. And we can see, and I'll tile these side by side, we can see it climbs up the road and swings around, and away we go. Now, if we wanted to use the approach directions, maybe we don't want it to come from over here at our endpoint. I happen to like the direction this is pointed with my existing road, so I'm not going to do anything at my start. But at the end here, I can come in here and I can say, well, at my approach, I want to control the directions. And well, in here, let's tell it I want it to come from that direction. Again, just so I avoid having too much clutter, I'm going to leave that remove existing features on. And it doesn't like that because, well, I can't adhere to my design curvature and grade with that. So I'm going to give it a little bit more freedom. And we'll let this thing think. Unlikely to improve. We'll hit OK, and we can see, well, it's keeping that approach direction within that line there and that line there. And we're staying below our 12% grade, and we are adhering to the 35-meter radius curve, minimum curvature that we're looking to use. And as the software considers this problem, well, it's looking at other parameters that Aaron introduced. So we've got our road width with that simple trapezoidal cross section. We've got our max cut and fill heights. And here, when it didn't like this, well, it's because I would have had too high of a fill or too high of a cut at one of those points that would have made it infeasible. And away we go. So that's a simple example, and I'll pass it back to Aaron before I go into the next example.
Perfect. Let me get my screen showing again. So that was Path Explorer, I'm going to say at its most simple. So we're really just looking at some of those core setup items, but now let's make it a little bit more complicated. Let's bring it a little bit closer to how you as an engineer are probably thinking about your problem in the real world. And that's including spatial constraints. So here we call our spatial constraints kind of construction zones. And construction zones really allow us to determine areas of higher or possibly lower cost. And there's a few different kinds of them. The first kind of construction zone that we sort of have to work with is a relatively straightforward concept. It's a no-go polygon. These can be great for, say, you've got an archaeological site, you've got a right-of-way constraint. Including that type of area as a no-go polygon will prevent Path Explorer from entering the polygon. So it fully restricts it. The next type of constraint that we have are something called a no-go polyline. Pretty similar to a no-go polygon, except for it's just a linear feature. This could be, there's perhaps a particular fish-bearing stream. You can't cross it. You can use a no-go polyline for that type of feature. And then the last one, which is probably the one that we see used the absolute most, is this idea that we can have either polygons or polylines that have differing cost. Our most common example here is if you were leveraging the streams and ponds tool within the software, you can now assign a crossing cost to any one of those sort of hydrological features. If you incur a cost for, say, a culvert, You can include that cost for every polyline you cross, or if you've got a major river, perhaps you're going to pick that particular polyline and assign a much, much, much larger cost to represent, say, a bridge structure. So you can use these tools, these construction zones, to add complexity to your model, whether that's for ground types, for stream features, for property boundaries. They're really, really useful for helping to control and influence how Path Explorer is going to behave and give it a lot more real-world realism to the search. So with that very brief introduction to what construction zones are, I am going to pass it back to Matt, and we're going to go take a look at our second example, which is, adding some spatial constraints.
Righty. So we've got another example, so much more benign terrain than the last one, but still more complex than the last one. I'm just going to make it so we can see our start and our end point here. So before I run this, taking into account those construction zones, let's see what it does without them. I'm going to go up here, and rather than just running with our defaults, let's say we want to have a minimum curve radius of 60, grades plus or minus 8. I'll leave my max cuts and fills. I'll leave my earthworks costs, and we'll hit OK. And it's going to take a moment here. And again, it's not a trivial problem. It's going to take a few moments to run through and look for, well, different possible solutions as it becomes more sure of, okay, these solutions that we're giving are good. So it's found 5 paths so far. It's looking for those better alternatives, and shortly here it's going to say unlikely to improve. We'll hit cancel then, and we'll run with that. So unlikely to improve, we'll hit cancel, and we can see, well, there's a few things I'm not crazy about with this. So one, I didn't control my approach direction, which I might have. But the bigger thing here is just looking at, one, the topography, and 2, the orthoimagery. That looks like a pretty lousy spot to put a road. We're going right across to what's most likely a bog, and then we're crossing and going across it again. So that, as the software searches through for the best place to put the road, it's looking at that trapezoidal cross section, looking at our cuts and fills, but it's not really differentiating the ground types or anything like that to be different. That's up to us to tell the software what to consider. So for our first iteration here, well, given that we've probably got some streams, or at least significant flow paths that we want to consider, and ponding areas, so wet spots, I'm going to run the streams and ponds tool. And of course, I could just insert that data if I had it already in another format, but I don't here. So I'm going to use streams and ponds, and we can see, well, where we likely have ponding, where we have, well, significant flow paths, and probably will need a culvert. So out of all this, I'm going to run the optimization tool again, but I'm going to click this. I'm going to go in here and I'm going to say, well, I want to account for some polylines. Those polylines are going to represent my streams and pond boundaries. I'm going to say each one of those crossings is $7,500. And we'll hit OK, and we'll rerun this. And again, I'm going to just remove my existing features because I don't like those first options. and we'll let this go. And again, it's not instantaneous. We're going to have to wait as it runs through, and yeah, larger, more complex problems and projects are going to take longer, but this one shouldn't be too long. Be surprised if it takes any longer than 2 minutes. So we're in luck, unlikely to improve. We'll hit cancel, and we can see, well, right off the bat, I like those solutions a lot more. So we're not going right through where there's obvious ponding issues. And I mean, there's gaps between the ponds here, but they're still wet. So I am, at a glance, more fond of these solutions, and I'd probably run with that. Now, if this came back as, well, I was, maybe we didn't capture something that would have been better captured by a polygon, where we're changing our earthworks cost rather than just having a crossing cost associated with it. Well, we could do that, and we could run through with our new feature functionality. So, and I could just draw in, I could delineate these wetland areas myself, and I could apply a polygon cost for those. Or if those features already exist somewhere else, I could bring them in. Rather than redoing others' work, we can run with those. So these polygons are my wetland polygons. And I could come in here. We could redo that Path Explorer run, but we can add in some polygon costs for these guys. So construction zones, we'll add in polygons. I'm going to select my wetland features from those. And I'm going to, well, say that my cut costs are really expensive. We probably don't want to be cutting that at all. And across it, our fill costs are going to go up. So it's going to act as a deterrent. We're going to hit OK. And this time we'll keep those other solutions, and we'll add to our options here. So we'll hit OK. We'll let this thing do its thing. And once it says unlikely to improve, we will hit cancel, and we'll see how that extra information we've given the software influences our solution. And again, not instantaneous. It's not a massive problem, but it's big enough. We're doing about 1 kilometer, and we can see, well, by adding that in, we're still kind of in the same vicinity, but it's doing a better job of crossing that at its narrowest point. And well, we could take that and we could run with that in, say, location as we refine our design. So with that, I will, we've covered an introduction to construction zones. I'll pass it back to Erin, and we'll continue to build on what we've covered.
Excellent. Okay, I feel like this is the right time to kind of chat a little bit about resolution. So hopefully you've noticed, as Matt is running the tool, there is a section in the Path Explorer dialog for resolution. And I think it's really important to kind of talk a little bit about it, and also to give a major disclaimer, which is we are doing a live webinar. We want our Path Explorer runs to be relatively quick, even though 15 to 25 seconds feels like any ages in a live webinar. If we waited for a minute or 2 minutes, it would feel a fair bit more painful. So please don't look at our webinar settings and copy them. Pay attention to this section of content. So really, what I'd love to help you understand here is that Path Explorer uses a resolution that's kind of similar to resolution of, say, topo data. And here's sort of a picture of a few different variations of topo data. Of course, LiDAR on the left, this data is far more detailed. And then as we sort of decrease the resolution, it gets a little bit blurrier. And I think this is a perfect analogy to what Path Explorer is doing in the background. So we have two different levers to pull on when it comes to resolution. The first of them is horizontal. If you have an opportunity to decrease your resolution, but paying very close attention to your problem size, or I should say increase your resolution, but decrease your number, for the horizontal, absolutely do it. In all of the examples Matt just ran, he could have been running them at a much finer resolution in order to get even better results. So, please pay attention to that as you go to do this on your own. And then of course, vertical, instead of giving it a finite number, we've got a bit of an algorithm running in the back that looks at your horizontal and then comes up with what that vertical should be. So we here in that section, we're gonna let you pick between high, medium, or low in terms of the resolution. And resolution, I should say, plays a pretty major role and has an impact on two things. First and foremost is the accuracy of your solution. Of course, the higher the resolution, the more accurate your solution. But then to the flip side of that, it has a very large impact on something that we call problem size. And problem size really sort of refers to the complexity, to the scale of the potential problem you have. And problem size is impacted by those two factors we just talked about, horizontal and vertical resolution. It's also impacted by your max cut, max fill. So this is kind of like your vertical band that we're looking at within the TIN model. And it's also looking at the area that's being included in our Path Explorer search. So your TIN model size, how large is it? And if you've potentially leveraged an AOI to hem that in, certainly that will help to reduce problem size. So these four variables really feed this idea of problem size. Path Explorer does display problem size for you as you are going about your searches. In the last couple of runs that Matt did, it mentioned it was a really little problem size. Again, intentional, live webinar. We don't want to make anyone, especially ourselves, feel impatient. So it's just something I'd love for you to pay attention to as you're going through. And here's an example. Same project, a few different resolutions. And in this case, we're just playing with horizontal resolution, and you can see the impact on the estimated problem size. So if your problem size is small, as is the case when we're running it to, at almost 30 feet and 10 feet, in this case, I would encourage you as a user to please try making your resolution better. Increase that problem size a bit. You're gonna get better, more accurate results. But on the far side of the scale, you've got an example here where we've gone down to 2 feet. And now the problem size is very large. And as our problem size increases, so too become the memory demands on your computer. And it's kind of a space of diminishing returns where, if you've got a really, really large problem, you might not be getting that much better of results. So always better, pay attention to problem size. It can help lead to, a more accurate result and hopefully giving you a better sense too of whether it's something your computer is going to be able to handle in a reasonable time frame. And then my last disclaimer for the last time, don't copy Matt's settings. He's in a live webinar. Okay, this concept of problem size and accuracy is particularly relevant for those of you who are doing long roads. So if you are doing a 10-kilometer road and you're looking to leverage Path Explorer, this presents a big challenge. Obviously, longer roads, bigger problem size. And there's a few different levers that we'd love to share with you that you can sort of pull on to help you solve the problem of Path Explorer for long roads. The first of those is reduce your TIN model size. You can use an area of interest. You can reduce that area, the footprint that we're looking at. So if you know that for sure you don't want a road to go over there in that one section, cut it out of the model or hem it in using a polygon. The second lever you have to pull on, and we just talked about it a little bit, is this idea of playing with your resolution. So start with a different resolution. You can try adjusting it as you get better results. Your next lever that you have to pull on is leveraging control points. And it's terrible writing here on the slide, but you can leverage control points to kind of segment your bigger road into a few pieces. And a really typical example of where we would suggest using this is, for example, if you have a known crossing site where it'd be, that's a perfect spot to cross that water body or that water course. Go A to B, B's on one side of your crossing site, then B to C on the other side. And that splits your long road up into a couple pieces, making it much smaller of a problem size. And then the final lever, which is really not a lever, it's kind of saying use the first three in combination with each other. But yeah, try adjusting your resolution, then use an AOI based on the search that you found and the results you're getting. Then leverage control points based on what you're seeing there. So kind of playing with all those other ones in combination can really allow you to start to solve some of these long roads. And bit of a preview, but in a couple weeks we're going to be featuring a client of ours, Anyway Solutions, which is a Toronto-based consultancy, and they leveraged Path Explorer for over I think it's about 250-kilometer road in the Papua New Guinea Highlands, and they're going to be stepping through a little bit of their process, a little bit of their learnings, and some really exciting details about their project here live in one of our webinars. So long roads, totally solvable with Path Explorer, but you got to be aware of some of the tools that you have at your disposal to make them happen. And with that terribly long-winded introduction, I'm going to go back to Matt. We're going to take a look at a few of those topics: accuracy, long roads, control points, and a really fun example. So Matt, coming back to you.
All right. So before I dive into my next example, I'm going to kind of talk about some of the results and ease into talking about accuracy, and then we'll set up a bigger project that, well, ties everything together. So that first example that I had here, we can see the Path Explorer solutions that it gave in my run. I told it to give me 5 solutions, and these solutions that it's given are not random, and well, it's not to say that we couldn't have something that maybe went all the way around and came back there. But the solutions that we get are within 15% of the cheapest. So it looks for what one is the cheapest and then give the 4 other most spatially diverse within that magic number. So here we can see if we're staying within 15% of the cheapest, well, they're all pretty similar alignments. But if we look at that other example that we just ran, well, these we can see that they're not way out there, but they're certainly more spatially diverse. So here we've got that option, that option, that option. And well, if we right click, select feature by name, we can see our different solutions here. And what are the ones that are shown? Well, that happens to be our cheapest. Those ones are very similar as well. So that's kind of where the options that it's giving are coming from. And then and before I dive into a long example, if we consider, well, all the information that we've introduced so far and talk about accuracy, well, Aaron mentioned that there is that point of diminishing returns where we can go with a smaller number for our resolution, and we may find that there's not much of a difference between the solution it gives. Now, with this, to help illustrate this example, I think a realignment is a great example to talk about. And with that, the Path Explorer isn't really set up to just say extract a center line from an existing road. So that's not what it's doing. It's looking at that simplified cross section and trying to find ways to minimize your costs to rebuild that cross section along your topography. So for this particular example, if I run A to B from here to there, and I have my parameters set up to be, well, I've got them set to represent kind of a 90km/h design speed. And I run this, well, the solution that I get varies depending on the horizontal resolution. So if I've got a few of these I've already run, so no one has to wait for me to click a button and let the computer think over and over again. But if I used my resolution at 5 meters and had my vertical resolution set at high, it gave me a solution that looked like that. So it, as I mentioned, it's not perfectly tracking the existing road, and I wouldn't expect it to perfectly track the existing road regardless of what resolution we put in there. But this one took about a minute to run, and we can see it does a pretty good job of following what's there. So my kind of take on that is, well, our initial our existing road is probably meeting our design speed, and these little spots where we're deviating from it is probably just a product of the simplified cross section that we're using, where it's not a perfect match. So if we, and that one took 60 seconds. If we look at the 10-meter solution, we can see very similar solution. If we go up to 20, again, a very similar solution, a little less, yeah, not quite as good at following the line. But if we go to 40 meters, suddenly it's not doing a very good job at all to capture that. And that is if we look at it, again, kind of think about it as the computer would think about the problem. With a 40-meter resolution, it's not really able to capture the existing road and how it visualizes the problem. So accuracy does matter, and the lower, or the resolution does matter. The lower resolution you're dealing with, the faster it'll run. And yeah, but there's often a tipping off point where you'll see that solution quality isn't what you'd like. Now that being said, as we consider it from a large project standpoint, using a reduced resolution from kind of figuring out high level, okay, I want to be in this valley, you can run really low resolution and then hem in an area of interest and run a higher resolution on that area of interest to get a better solution. So that's enough of me clicking around in the software, introducing the idea of tackling long roads and some of the considerations between accuracy and speed. And let's look at, well, one that's not a massive project, but I think it is enough to introduce concepts. So this project is, well, a realignment project. I want to go from here up to here. So the existing road is kind of that 90km/h design speed for the geometry, and I want to bump it up to 130km/h design specs. So it could be twinning, it could just be improving what's there, but there's a good chance here that the existing geometry isn't going to be a whole lot of use to meet my needs. So major realignments are kind of on the table. And if I were to define my start point and my end point and let this thing go without any construction zones defined, I would expect the software would find the cheapest solution is to go from here down onto this flat spot and pop back upwards. Convenient. Now, of course, that is a lake. It's going to be really expensive to build a road in a lake, and practically speaking, it's probably better if we just avoid it and put in a firm do not go there. So I'm going to make a feature just as I did before. We're going to go from here out to here. And then we're going to go to the optimization tab. And while the default settings that I have shown aren't really going to be a good representation of what I'm looking for. So I don't want a lot gentler turns than 35 meters. In fact, I want to go under 830 meters for my minimum radius. Grades, I want to keep it around 8% max grade. Costs, well, I could chunk it out for different kind of geological units and say some are more expensive than others, but this one, it's really going to be rock dominated, so I'm going to increase my cut cost more than usual. And of course, this isn't going to be a gravel road, so I'm going to bump up my surfacing cost per square meter here as well. Now, it's pretty humpy bumpy terrain. I would be surprised if I could get something to run with max cuts of 5 and 10 meters. So I'm gonna, 5 meters. I'm gonna bump those up to 10 meters. And well, I'm going to reduce my resolution a bit. So I can see it's saying that it's a very large problem. I'm gonna hit 20. It's still very large, but the number reduced. So it's still a big problem, but we'll make it less big. Now that's my defaults. I'm going to go in here, construction zones. I'm going to click new to add in my construction zones. I'm going to add in a cost for my streams. I'm going to just select all my stream features. And I'm going to say, well, those stream features are 50,000. And then we're going to go in here and we're going to say, well, no-goes, that lake is a no-go. There's another smaller lake in there that is a no-go. Some of those other polygons are just where we expect it to pond and storms, but there's 2 lakes that I don't want to infringe on at all. And I'm going to hit OK. And well, briefly there, it said it was checking feasibility, and then it's throwing me an error. So it's saying that problem can't be solved given the design standards that I put in there. And if I had have gone with a smaller resolution, it might not give me that firm, it's not going to solve warning. It might just say that this problem is going to be probably quite difficult to solve. So we'll see that when this is the case, it's going to take longer to check feasibility, and it'll tell us that's probably going to take longer, and there's a chance that it might be infeasible. So both of those warnings, the infeasible and the Problem's a big problem warning are, well, indications that maybe I should consider leveraging some of the strategies that we have up our sleeve to work with these larger projects. So this is the problem is difficult and possibly infeasible. So rather than dealing with this as a whole, and well, I'm going to take that warning that it gives sincerely, and I'm going to consider, well, what I've told the software. So I've told it that I want to run with a, well, fairly gentle turning radius. Max cuts 10 meters, max fills 10 meters. So is there any reason this isn't going to be feasible? And well, if we zoom in right here, we've got a canyon. In order to cross that, we're stuck being higher than 10 meters in the air. And we could, well, bump our max cuts up and up and up and up until it'll run. But here, this is a control point. So rather than considering this as I want to run from the start point to the end point, I can make the problem significantly easier to solve if I chunk it up and I daisy chain these solutions along. So I'm going to take that start and end point. I'm going to say, well, I want to go to about there. I'm going to break my feature. So we've got our start point, our end point, and we're going to do the first part independently. And now here, if I do this, well, I probably want my road to start being pointed in one direction. I want it to end coming in from the south. So we'll hit OK. Oh, and actually, another thing, still a large problem. I'm going to reduce that resolution down so it's, well, faster to solve. So 5 paths, looking for better alternatives. Found it pretty quick. And well, away we go. So we're hemming in there. Next portion of our geometry, we can do the same. Now I'm going to move this off my starting point a little bit. I'm going to leave it a little wiggle room so I can get this pointed in the direction I'd like, because my approach directions, it's giving a zone, not an exact direction for how it starts and leaves. So we've run A to B. I want to have my B to C with my current selected feature. And I don't want to remove that first part because I'm going to connect those 2 lines here afterwards. So same settings, only difference that I've chunked it up in the middle, and we'll hit OK. And this chunk is, well, longer, so 9-ish kilometers. And we can see it's looking for better alternatives. And we'll let it narrow in, unlikely to improve further, and we'll hit cancel, and we'll hit OK. And so here we can see, well, of those different solutions that it's looking for, well, some of them are using the existing prism to help, well, reduce costs. Others are finding entirely new routes to run through there. So of course we could take those and we could explore each one of those individually, or we could narrow in on what ones we'd like to focus on. And so if I look at these guys at the start, well, that is my cheapest solution here. Where we come up and we aren't, I'll zoom out so we can see it on this, we aren't swinging wide, we're staying relatively high, and seems to make sense. We're using another existing road prism as kind of our starting point. And then on the other end of things, we can look at these solutions, select feature by name, and well, let's see what one here is expected to be the cheapest. Again, not the one that's following the existing geometry, but instead we're swinging high and staying up on that plateau rather than in the gnarlier terrain where the existing road is. And if we wanted to run with that as our solution in location, well, I'd select both of those Path Explorer solutions in terrain. So both are selected right now. I'd right click, modify, join, and I'd take that over into location. So with that, that is my quick, I guess not so quick, spiel on long roads. A couple other things that we could have done here instead of, well, just chunking it up into a single alignment. I could have said, well, I know I don't want to go outside of a polygon. Maybe for that second one, I wanted to run with a higher resolution, but I know I don't want to go outside of this line here. So I could draw that in and we could run Path Explorer on that solution. But we could have said that, well, this feature here is a no-go polyline, in which case it's not allowed to go across that line. So it's good to make big problems small. Also a good tool in the toolbox if you're dealing with a project that's already been started and maybe you have a permitted right away where you have to keep your design within. With that, I'll pass it back to Erin.
Okay. Final sort of official section of content, and probably the one with the least amount of slide information. But what we've been doing so far is we've been playing in the terrain module and essentially creating, although they're not actually just lines on a map, in terms of what we visually see, just some lines on our surface. So from there, we're going to take, I think, another 2-3 minutes just to quickly show you what that sort of process is to take from the terrain module, one of those Path Explorer lines, convert it into what RoadEng is really known for, which is that full 3D geometric road design. So that's kind of our next step. We'll head back over to Matt, probably pick up one of our easier examples and move into the software. But before I do so, I want to highlight a couple limitations, especially because it's got the word AI in it. I don't want anyone to think that this is a magical tool that is going to do their full detailed design at the click of the button. Nope. This is really a preliminary design tool. It is amazing at what it does, but it by no means replaces your professional opinion. This gives you a starting point. It changes your question if you're out in the field. For field time, it changes the question of where should I put my road to why shouldn't I put my road here? So some really important limitations to consider. But what Path Explorer does, and just to maybe recap it a little bit, it really does thoroughly assess parameters. It performs very fast, even though sometimes those 30-second runs in a webinar feel like it's really forever. But it operates really fast. It can account for more than earthworks, as we talked about some of those spatial constraints. It also allows you to iterate and compare different options and adjusting different variables and seeing what the impacts are. And then, as we're going to show you right now in our final piece of the webinar, it integrates into our location module to allow you to get a more detailed design. And with that, example number 4, let's take Path Explorer a little bit further. Matt, back to you.
All right, so I will go back to one of the simpler ones. Just I'm going to do a vertical optimization here. So rather than waiting an extra minute because I've already gone over time, we'll take something that should run quite quick. So our example where we had the streams and whatnot in there, we can select which alignment we'd like to run with. It could be based just off lowest cost, or it could be, well, I like that one. So we'll hit save. We'll go over to location. We are going to click new file, and of course I should grab the one I want. So I'm referencing my terrain file that we've saved that has our topo surface in it and our Path Explorer feature that we'd like to use for our initial alignment in it. So here I'm going to just use, well, the currently selected feature as my initial alignment. Start out with multiple if we wanted, but we'll just do one. And I'll click zoom to extents here so we can see what we're up against. There's a couple housekeeping items that I'm going to do as I get going with this that are pretty consistent from project to project. One, I'm going to make sure my cross-section geometry represents what I'd like. So this is a paved road prism. The example I'd like to run with here is just going to be a simple gravel road. We could build these templates out to be really whatever we'd like, but I'm going to just use that default gravel road template for this one. And then the Path Explorer solution that we have, it's considering our turning radius as we, well, as it searches for the alignments, but it's producing a polyline. So I'm going to take that and I'm going to turn it into a proper alignment. So a series of curves and tangents. And so this tool that I'm running, it's going to, well, reduce the number of IPs to stay within a tolerance that I have set. So this tool is, well, I'm using it in the context of a Path Explorer project, but you can use it on other features as well. So if you were dealing with maybe an overlay and widening project and you had a surveyed center line, well, you could use that polyline to alignment functionality for a surveyed feature instead of Path Explorer feature. So we've got our start point, our end point, our horizontal alignment from Path Explorer. We've got our cross section defined here. I'm going to go over to the vertical optimizer and I'm going to tell it to optimize my road. And I'm going to say, well, I want to have my cuts and fills, or sorry, my grades, 8%, my crests and sags, whatever I'd prefer here. So I'm going to go 8 for both of those. I can add in a control point if there's anywhere I'd like to be at a specific elevation. And well, I could add in other constraints, maybe a minimum fill, embankment depth, or full bench constraint or direction constraint. But I'm going to, again, seeing as I've already gone over time, I'm going to just keep it simple and we'll run with what we have here. So I'll hit this. It's going to do another optimization where it's looking to minimize my cuts and fills for this project by moving my vertical alignment up and down while adhering to the material that I've told it that it's there and the design criteria that I've told it to follow. And it shouldn't be long. And we've got an alignment. So we can see our mass haul is very close to balancing. We have, I guess, our big cuts and fills on this one were 200 cubes going through there. Well, I guess minus 200 to plus 200, so a 400 cube cut, but very minimal, and all that material is getting used for the approaches of it, so very economical use of material. We can see our volumes being summarized down here. So cutting just shy of 1,800 cubes and filling just right around 1,800 cubes. We could add in culvert if we want to add in our culverts. And we could produce our documentation in here. I'll just bring in a predefined workbook. So there we are. We've got our plan over profile. Again, if we want to customize things, we totally can move things around. And we could obviously build out our documentation to represent our own personal standards, but this document is the It's the one I like to run with. So with that, my spiel is, yeah, I think I've covered what I was planning on covering, and I'll pass it back to Erin.
Excellent. Okay, we're going to take a moment to acknowledge the fact that we are over time. Wouldn't be a classic Softry webinar without going over, but we'd love to hang out, answer questions for a couple minutes. So while we give you a moment to type some of those questions into the chat, wanted to highlight two things. I know we mentioned in this past section we were going to take Path Explorer further. We showed you how you could take a Path Explorer alignment further. But if you're interested in seeing how we are taking Path Explorer as a whole tool and function group further, we are doing an exclusive webinar coming up on June the 12th that's previewing our new versions. There's some massive changes coming to Path Explorer, including some new speed improvements, actually, I don't want to give away all the exciting, awesome stuff. But if you're interested, feel free to go to our webinars page, register for it. Version 12 sneak preview. And this is also going to cover some of the other really exciting functions that are coming in 12, such as intersections. And then the other piece, we'll go pivot here in a second to go answer those questions, is that webinar I mentioned with our partners from clients, I should say, over at Anyway Solutions. We're going to be showing Path Explorer AI in action on a real project through some absolutely amazing terrain in the highlands of Papua New Guinea. So that's coming up in 2 weeks today at our standard webinar time of 11 a.m. Pacific. So hopefully you can join us for that. And with that, let's get into a couple of these questions. The first one, potentially already answered, and Matt, I believe this was asked during example number 2, and it says, I see an existing road. Can you run your point-to-point tool on the existing road to find the optimal path and use that path as a starting point? So this was done on your bog example when that question came in.
Perfect.
I'm
So
happy
yeah,
to make the presenter again if you want to talk about it.
I won't rerun any of the optimizations, because I did try to incorporate that as we ran through the long road example. So it's not going to automatically or reliably give you a perfect match of existing roads if they're there. So, and I'll go back to yeah, we'll look at this example. So yeah, if we grab one of these, so we can see that it's doing a pretty good job of following the road, but it's certainly not matching the center line of this line is probably not right on the crown. But the tool can be kind of used as that front end check on fairly irregular terrain. It does trend to follow existing roads quite well. If you're on really benign terrain, and it's really with that lens that the software is seeing the problem, it might not, if you've got a flat road versus a flat field, it might not necessarily pick up that there's a difference associated with that. So if it's not really driven by the topography and geometry, and you want to check if your alignment is generally following your design speed, a trick you can do there is take your, if you've got some kind of a line for the existing road, just buffer it out so it has a polygon and reduce the costs for your surfacing on that part of the topo. Assuming that you want to reuse the road and maybe widen it, you can reduce your surfacing cost in a polygon, and then you'll see that it tends to follow it unless it makes sense not to follow it. But yeah, not necessarily something that you're going to use for being plus or minus a couple inches of center line. Hopefully that makes sense.
Awesome. Thanks for answering that one, Matt. Your next question. Can Path Explorer work for projects that are not roads?
Totally. Yeah, so at its core, well, it's considering an alignment with constraints, and it's considering a cross section. So it does really well on projects that are similar to that. So pipelines, great. Trails, great. Yeah, kind of all those problems that well, you're moving dirt relative to a center line and a cross section. Yeah, so it's not specific just to roads, but I think roads are definitely the most common use case.
Okay, let's do a couple more. Some really great questions here in the chat. The next one, instead of cost, can you use Path Explorer based on cut and fill volumes?
Yeah, so the cut and fill costs just $1 per cubic meter. If you wanted to consider that as volume, you could just go to 1 for both of them. But yeah, it's using a simplified cross section meant to be that front end tool to get your road in the right location. If you are really focused on getting volumes for your project, your best bet is to take the extra 30 seconds and take it into location and apply a cross-section geometry that represents your cross-section geometry and optimize the vertical.
Excellent. Okay, let's do one more. And this question, I feel like could be an entire webinar on its own coming up in the near future, but it's about wind farms and connecting multiple turbine sites. So how do you recommend connecting lots of different points in a road network for a wind farm?
Yeah, so the multiple aspect is really the same as that daisy chaining technique that we used on our long road example here. You're gonna currently just consider it as a series of individual roads and connect your points with several Path Explorer runs. But yeah, it's kind of, we'll allude to it, but there's some more really complementary functionality for that coming in version 12 that we'll get into on that version 12 webinar.
Yeah. Awesome. And maybe we should leave it there. We are only 20 minutes over time, or 22 minutes over time. Goodness. So just kind of doubling down on what Matt said, if you are interested in seeing sort of the next generation of Path Explorer functions, version 12 preview, some really exciting stuff, especially when it comes to working with those larger networks of points and how to connect them. And with that, thank you all, first off, for hanging out with us for an extra almost half an hour. We covered a lot of ground in this webinar, going through 3 full project examples for path exploration. We hope that you've picked up a few tips, tricks, and tools that you can implement as you go to use the tool yourself. And hopefully it's kind of giving you a better lens to understand how it's working so that you can control it even better. Thank you as always, Matt, and we look forward to seeing everyone at another upcoming webinar again soon. I think we're going to be doing one almost every week for the next month, so be sure to check the calendar, and we look forward to seeing you all back here. Thanks, everybody.
Thanks, everyone.